Good afternoon, Robert Scribbler. It is April 15th, 2019. Thank you for joining me for another climate change and clean energy video blog. Now for this segment, I am going to refocus on climate change for a little bit. I want to take a look at major climate indicators at present and help to provide you guys with an idea of where we are with regards to the present global climate state. But before I do that, I'd like to talk a little bit about ongoing protests being conducted by members of the youth who are very concerned about climate change. Young people right now have a major reason to be very worried because they will experience the worst effects of climate change. Although for anyone paying attention at this time, it should be obvious that we are seeing impacts now. So the impacts of human-caused climate change are impacting everyone living today, but over time, those impacts will tend to grow worse unless we somehow manage to halt massive carbon emissions in the form of fossil fuel burning and also learn how to draw carbon down from the atmosphere. And this would likely require major effort both on the parts of individuals and businesses, but also major participation by government, which is one of the reasons why young people right now are so involved in protests, because they're really working to try and get the government to listen to them and to hear their needs and to respond in a way that helps both them and everyone living here on planet Earth. Now, recent news is about Extinction Rebellion, which is just one subset of the larger global climate movement. And this particular group has had a lot of effect in Europe recently, and it appears that these protests will be global and they will tend to go on for some time. I just like to note that I am very supportive of the global climate movement and the efforts to get the politicians to wake up and to, more importantly, remove the kinds of politicians that stand in the way of climate action. Now, moving on to present global climate indicators, I'd just like to show you this graph here from the Mauna Loa Observatory as produced by NOAA's Earth System Research Laboratory, showing the inexorable rise of atmospheric carbon dioxide since the 1960s, with a recent acceleration in the rate of atmospheric CO2 increase. Now, according to NASA, carbon dioxide is the primary greenhouse gas that is driving the present climate change that we see and the climate change that we will see over the next century and likely for many centuries to come. And there are other atmospheric greenhouse gases that add a heat trapping effect on top of that of carbon dioxide. And it's worth noting that the total atmospheric CO2 equivalent of all the gases that human activity, primarily fossil fuel burning and fossil fuel related industrial activity, has pumped into the Earth's atmosphere is roughly equivalent to, during 2019, 497 parts per million of CO2 equivalent. Now these values, the present values in the range of about, on average, the global average is around 410 parts per million. We're going to get into some more direct CO2 figures for this month in just a couple of minutes. But this range between 410 parts per million and 497 parts per million CO2 equivalent roughly bound a range that is equal to atmospheric greenhouse gas forcing during a period about 15 million years ago called the Middle Miocene. Now, temperatures during that time were about 3 to 4 degrees Celsius warmer than 1880s averages, or about 2 to 3 Celsius degrees warmer than today. So what that implies is that if atmospheric carbon dioxide levels even just remain stable at the high levels that we see today, that we have more warming locked in over the long term. And if we keep burning fossil fuels, if we keep emitting greenhouse gases into the Earth's atmosphere, then the Earth will warm even more over the long term. Now, 2 to 3 degrees Celsius of additional warming is really bad, so what we need to do is not only stabilize atmospheric carbon levels, but learn how to reduce the total atmospheric forcing from gases like CO2, methane, nitrous oxides, and other atmospheric greenhouse gases. And this is a major challenge. It's in my opinion the challenge of our age, of our generation, and the future of human civilization will in many ways be determined by how rapidly we transition to clean energy, and how sustainable our human systems become, and how well we manage to learn to pull down carbon from the Earth's atmosphere over the longer term. So looking at the present month, and this is in keeping with trends, annual trends in which atmospheric carbon dioxide levels tend to peak in April and May due to the variability of foliage, primarily in the northern hemisphere. We are at present seeing atmospheric carbon dioxide levels range from around 410 to 411 parts per million on a daily basis on the low end at the Mauna Loa Observatory, and up to nearly 416 parts per million on the high end. And it looks like, and these are record or near record daily values, and we're going to push into more and more record daily value territory as we get into late April and early May, due to the way the carbon cycle works on the Earth's surface. And it appears likely that during May, atmospheric CO2 averages for the month will likely range between 413, more likely 413.5 parts per million, all the way up to around 415 parts per million. That's a little bit less likely. That's on the high end. So most likely around 413.5, maybe 414, maybe a little bit higher than that. But these values are very high. They represent a context that is well outside that seen for human civilization, and the climate context that just for the value of CO2 likely hasn't been seen in at least 5 million years, and possibly more. So this heat-trapping gas creates the context in which the Earth is presently warming, and at present we are seeing temperatures in the range of about 1 to 2 degrees Celsius above average. Above 1880s averages, which is the start point for the NASA monitoring system, which is the longest running comprehensive global temperature monitoring system. So during March of 2019, we saw a very warm climate, and I'm just going to show you this picture provided by NASA, which shows temperature anomalies across the global surface. And as you can see from this particular illustration, that most of the world experienced warmer to much warmer than normal temperatures, with considerably warmer than normal temperatures over a large section of the Arctic and the upper northern hemisphere latitudes, to include Alaska, northern Canada, a large swath of northern Russia and northeastern Europe, as well as the Bering Sea. Now these temperatures, these much warmer than normal temperatures, have helped to push Arctic sea ice into record low ranges. We're gonna talk a little bit about this, but it's worth noting that the Bering Sea in particular saw very low ice levels for the month of March. Now, these temperatures in the range of 1.11 degrees Celsius above NASA's mid-20th century baseline are around 1.33 degrees Celsius above 1880s averages. And I just want to show you this particular spreadsheet in which NASA keeps track of comparative global temperature departures to show you that here we see in the lower left that March of 2019 was the third hottest on record in the 139-year global climate monitor provided by NASA, and that the December, January, February measure from NASA for the climate year for 2019 was also the third hottest on record. So these warmer than normal temperatures are in the range of what we would expect given the climate that we are seeing. We are presently moving into a weak El Nino phase. I want to talk a little bit more about that because it's possible that we could see some new record hot temperatures broken for 2019. I'm going to go into that a little bit more, but these temperatures are definitely in the range that we would expect and that climate scientists have predicted based on how much atmospheric greenhouse gases have been injected into the Earth's atmosphere and how rapidly the Earth system tends to respond to those temperature increases. And so just before I start talking about Arctic sea ice, I'd like to point out this particular graph, which was posted by NASA GISS scientist Dr. Gavin Schmidt, who is showing that the predicted values for global temperature related to scientists' analysis of how much greenhouse gases would tend to heat up the Earth's climate over time has borne out according to a number of the climate models. And at present, we are in the range of what was predicted based on the climate model forecast. Now, looking at another major climate indicator, I'd like to talk a little bit about Arctic sea ice. And here, let me back out of this. That's not what I thought it was. Here we go. And so at present, Arctic sea ice extents are now in the range of lowest on record for April 14th, which is just yesterday. The National Snow and Ice Data Center posts this graph called their Arctic chart. The site is Chartic Interactive Sea Ice graph, and it's their Arctic and Antarctic charts showing Arctic sea ice values as they depart from a baseline that was set in 1981 through 2010. Now, this baseline is not necessarily representative of a stable baseline. Arctic sea ice was falling into decline throughout much of the 20th century, and during recent decades has seen more and more rapid declines. So the period of 1981 to 2010 was a period in which we saw significant Arctic sea ice extent, volume, and area losses. So that baseline is just a snapshot in time of the climate state between 1981 and 2010. And at present, the Arctic sea ice values are about 1.4 million square kilometers below that baseline for today. Now, looking at recent years, I'm just going to go ahead and highlight the trends from recent years for Arctic sea ice. And going all the way back to 2003, we find that today's Arctic sea ice values, or yesterday's Arctic sea ice values, are the lowest on record. So the very warm temperatures that we saw in the Arctic in March have had their impact, and this impact has been yet again to knock the Arctic sea ice into new record low ranges. Now, Arctic sea ice is a major indicator for climate for a number of reasons. One, the sea ice sits on the surface of the ocean. It's an indicator of ocean surface warming. If the Arctic sea ice is melting more rapidly or hitting new record lows, it's an indicator that the oceans are warming up. It's also a larger indicator for the Arctic environment. In many cases, scientists thought that they wouldn't see such high levels of sea ice loss for many decades to come, but the kinds of sea ice losses that we're experiencing now are surprising and disturbing. The other issue for Arctic sea ice is that the ice itself during the summertime acts as a big reflector of sunlight, which prevents the ocean from gaining heat during the Arctic summer. So if the sea ice extent is less, then the Arctic Ocean relatively tends to gain more heat during summer, which has knock-on impacts to the Arctic environment. Yet another reason why we tend to see the Arctic warming up more rapidly, and why we have tended to see these anomaly values just showing up in a very visible fashion for the Arctic, and as an indicator that the Arctic itself is the region of the world that is warming the fastest due to human-forced climate change. Now, for the last climate indicator, I'd like to talk a bit about El Nino. And according to NOAA's El Nino report, which comes out every Monday from the Climate Prediction Center, the present state of the Pacific Ocean is in a weak form of El Nino, and that these weak El Nino conditions are likely to continue at least for the next few months and possibly through fall. Now, a weak El Nino is so let's talk a little bit about the climate variability feature that is the El Nino Southern Oscillation. And this climate variability feature tends to wag surface global temperatures. What tends to happen in the Pacific is that the equator goes through these periods of relatively cooler surface temperatures called La Nina, and relatively warmer sea surface temperatures in the equatorial Pacific called El Nino. Now, because the Pacific Ocean is so large and this region of water contacts much of the atmospheric circulation, particularly at the Earth's surface, this periodic cooling and warming tends to have a variability effect on the global surface temperature. So when the Pacific Ocean in this region tends to be cooler, the surface atmospheric temperature also tends to be a little bit cooler. And when this region tends to be warmer, the surface atmosphere tends to be warmer as well. And we can see this influence in the global temperature record. When you've had El Nino, temperatures tend to be a little higher. When you have La Nina, temperatures tend to be a little cooler. Now, this does not have an impact so much on the overall trend of warming that has been driven by the accumulation of atmospheric greenhouse gases in the atmosphere. But what it does have an influence on is when we have tended to see periods when global temperature hits new record highs. And these periods have tended to occur during El Nino, particularly during moderate to strong El Nino events. Now, at present, the El Nino is relatively weak, and what we're likely to see with this El Nino, according to NOAA's predictions, is that it will tend to be weak. So it's possible that 2019 might exceed the record high temperatures that we saw during 2016, but that's less likely due to the fact that El Nino is presently expected to be weak. Now, one of the major experts on the likelihood of new record temperatures is Dr. Gavin Schmidt, and if you're interested in figuring out what might happen for 2019, whether or not we will see a new record high global temperature due to El Nino, you might want to consult with him. Now, it's my opinion, and this is just based on a rough extrapolation of trends, that we're likely to see 2019 end up between the third and first hottest on record. So I think we do have the potential to see a record warm year during 2019, but there's a caveat to that because El Nino is presently so weak. I'd just like to call your attention to NASA's global surface temperature monitor in passing, and noting that the present trend line for 2019 is running about third warmest on record, but as we get into April, May, and June, it's likely that we'll tend to see these values get closer to the record high line, if not exceed them, as the influence of El Nino does tend to strengthen following the tail end of El Nino. And we're getting into the the mid to tail end of this El Nino. Now, so what we would tend to see happen is that the next dot, say for example, in this global temperature chart provided by NASA is likely to be up in this range here, probably in the range of, well, most likely in the range of at least second warmest on record, maybe providing a decent challenge and possibly edging out 2016. But what we're not likely to see for 2019 is another major global temperature departure, I don't think, in the range of what we saw during 2014, 2015, and 2016. Maybe a little bit of a bump on the higher end. So just an overview of present climate indicators. What we are seeing at this time is third hottest March on record. Looking forward to very warm near future months that possibly challenge old records. We're seeing record low sea ice, and we're seeing record high atmospheric carbon dioxide values, which is the major driver of the longer term climate change, human caused climate change, primarily driven by fossil fuel burning that we are seeing today. Thank you for joining me. For my next video blog, I'm going to return to more talks on what I'm doing personally, individually, as part of my own climate action. But this is just setting a marker out there, letting you guys know where we are at present. Thank you for joining me, and I'll be chatting with you soon.